Again, on that 653, go ahead and answer questions A through D. Okay, A through D, go ahead and answer those to the best of your ability, and we'll give you like a couple minutes to do that. Oh, it's connected. It's connected right there. Yeah. Yes. No clue. Did you read the scenario? Okay. So what kind of triangle is formed by the flagpole, its shadow, which is right here, and the ray of sunlight, which is right there? You see it now? Okay. We're on page 653. Just going to read A through D, answer those as best you can. Read A through D, answer those as best you can. Yes. The shadow, so a shadow normally is on the ground, right? You see a shadow. So like there would be the shadow, there would be the shadow of the person, right? But then this being like the sunlight. So the sunlight would hit this, right? And then because this is blocking some of the sunlight, it creates this shadow. And same thing here, there's the person, that's the sunlight ray, and again, the shadow. The shadow being blocked up until the sunlight that hits the top of the person's head, and then it's not gonna, you won't see more shadow there. You kind of get more of an idea of the picture there now. One little piece of information I may do to help you here for letter B, I'll go ahead and say that we're going to assume that the person and the flagpole are both kind of on the ground, on the same kind of like piece of ground there. So you can kind of like assume they're along that one piece of ground. Maybe like a minute and a half more to kind of work through this. Think about it. Yep. So, good question, right? So obviously the flagpole, that's the height we're trying to find, so we wouldn't really be able to know that. Some people, for example, know their own height. You know what I'm saying? So like if you just, so a known thing would be like probably your own heights, right? If you were doing this, you would know your own height. But some people don't even know that, so you might put none in that case, right? But then what measurements could you measure correctly? Well, then you have these things on the ground that are easy to measure. Your height would probably be an easy one to measure if you didn't already know it, kind of thing. But if that flagpole is going to be a little bit harder to measure. Mr. Wig can't grow anymore, though, and he's always going to be 5'7". Womp. Dang, James. Dang. I believe it. I believe it. Okay.
Let's get back together here. So, Liam, letter A. Okay, what kind of triangle is formed by the flagpole, its shadow, and the ray of sunlight? A right triangle. Very good. Okay, and just in case, just to make sure we're all on the same page here as far as this goes, right? This is the flagpole, right? That's the shadow of the flagpole. That is the ray of sunlight kind of coming in. Okay, so the sun's like over here, and like striking that. Okay, creating the shadow. Okay? Very good. Let's go on here. Jennifer, letter B. Okay, so suppose the sun is shining and you are standing near a flagpole, but out of its shadow. You will cast a shadow as well, right? Of course, right? So you can assume that the rays of the sun are parallel. So in other words, rays of sun here and here are parallel. What do you know about the two triangles that are formed? What do you say?
I just said that they are similar.
They are similar. Okay, that's a great thing to say. They are similar. Okay. Can you describe how you know they're similar?
Not really.
It's just like, well, they look similar. Okay, fair enough. Thomas, can you?
Because the two rays are both parallel,
Okay.
and assuming that the ground is level,
Uh-huh.
that forms two angles.
These right here?
Yep.
Yes, they're corresponding. Is that what you're going to say, Aubrey, too?
No, that's probably better than mine.
Okay. So yes, these are going to be corresponding angles right here. They're corresponding, okay? And so these triangles are similar by what? Angle. Okay. AA. Okay. So that's significant. In the diagram, what heights or lengths do you already know? So it could be none. Did anyone know any of the measurements already? Alex?
The right angle would be 90 degrees.
Okay, so we have 90-degree angles there. Okay. But what about heights or lengths, though? Do we know any of those? Yeah, Reed?
Since it doesn't give, well, I don't know, if you're assuming that the person standing is you could give the height yourself.
There you go. Yeah. So it's like, some people know their height. Of course, you guys are teenagers, so that's probably like a constant changing thing, Whereas once you become an adult, it stays where it is, okay? Well, I guess as you get older, though, you lose bone density and then you start to shrink again, too. So, but anyway, that's a different story, okay? So drink your milk and eat your calcium so you don't shrink, okay, when you get older. But anyway, letter D, what height or lengths can be measured directly? So which of these things can we measure directly? Well, we can measure the height, right, of ourselves if we don't know that already. What else can we measure directly here, though? Fairly easily. Yeah, I'd say the shadows as well. Okay? Either of the shadows, we can measure their lengths. Now, I had a student in block 2 that pointed out, well, we could measure the height of the flagpole technically, right? Especially most flagpoles have, the string attached to them, so you could, do something with the string and, get the measurement that way. Are you all done? Okay. I just want to put it on my desk right there. That's fine. So that's an option 2. But, of course, we're going to use the similar triangles to find the height of this flagpole and stuff. Okay? So, turn the page there, and we'll actually talk about that here. So then, it's still warm, so don't grab it. Oh, okay, very good. You got it. Thank you. Very exciting. Okay, so how could you use similar triangles to measure the height of the flagpole indirectly then? What could we do? How would we then use similar triangles to find the height of that flagpole? They will call it x. What could we say? How can we end up solving for this unknown measure? Idris? Okay, so find the height of the person. Yep, we'll see you, Gabe, right there. Okay, and so we'll say the height of the person. Okay, and put that in a ratio with? Okay, so you want to say height over shadow, like that? Okay, so height over shadow. Ooh, there you go. Height over shadow equals then x over the flagpole shadow, yeah. Okay, exactly right. Okay, exactly right. We're going to set up some ratios here and find that missing height. Okay? So I'm going to more generically just say set up a proportion. set up a proportion to find the missing height. Okay? Nothing fancy here. Okay. Oops, I'm off the screen. Actually, let me just do this. This will be easier if I do it this way. Oh my gosh. So, there we go. Set up a proportion to find the missing height. Okay, so now that we've beat that horse to death, I think, we can actually try a problem, all right, that's in the book here at least. So let's take a look at the scenario right here. Okay, so in this scenario, in order to find the height of a palm tree, you measure the tree's shadow, and at the same time of day, you measure the shadow cast by a meter stick. So here's a meter stick that you hold at a right angle to the ground. Okay, so you can see here the meter stick casts a 1.6 meter shadow. And so you have a palm tree here that casts a 7.2 meter shadow. Why is it important that they put in the at the same time of day little clause there? Why is that important? Read. Right, your shadows are going to be different depending on the where the sun is. Okay, where what time it is. You know how high or how low it is in the sky. So it's important you do it at very similar times there. Okay. So, based on this given situation here, we do have similar triangles by the same principle, right? These corresponding angles will be congruent, so they're going to be angle similarity there. All right. So, let's go to Matt. Matt, what would be the ratios that we could set up here in order to find the height x of this palm tree? 1.6 over 7.2 equals 1 over x. Sounds good to me. 1.6 and 7.2 are corresponding. The 1 and the x are corresponding. And so then we can cross multiply and solve here. So 1.6x equals 7.2. Divide both sides by 1.6 and you get 4.5 meters. Okay? This technique is a technique that's been used for like thousands of years. Okay? Before, we were able to before lots of technology and stuff like that. I mean, I feel like this has been around for a very long time, okay? Using kind of similar triangles to help solve for and find heights of things and stuff like that. Okay, so very old mathematics we're doing here. All right, let's try another one. All right, so here we've got Sid. Okay, Sid is 72 inches tall. So this is Sid. He's very thin, okay? And then his shadow is 48 inches. And then here is a flagpole with H for its unit, for its measurement and height, and then 128. Okay, so again, what would be our ratio we can set up here? Let's go to Isabella. Isabella, what would our ratio be here?
It would be 48 over 128 is 72 over H.
Yeah, you got it. Very good. 48 over the 128, they correspond, and 72 over the H. Cross multiply and solve, we get 48h equals 72 times 128. 9,216, and then divide both sides by 48. H is 192. 192 inches. Please make sure you do include units. Please make sure you do include units with your calculations here. This is in a context, so it's important to include those units. Because of that context. Questions on that right there? Pretty straightforward, right? Pretty straightforward stuff. Not too tricky. So why don't you guys go ahead real quick, take a minute, answer that your turn on the next page. Liam is 6 feet tall. To find the height of a tree, he measures his shadow and the tree shadow. The measurements of the two shadows are shown. Find the height h of the tree. Okay, so go ahead. Give those a try. Go ahead, try number 3. Give it a shot.
think it was right, or did it seem right to you, or? Okay, yeah.
Yes. What'd you get?
Don't forget units, but yes.
Yeah.
Okay. Jordan, help us out here. How do we set up a ratio?
I did 28 over 8 equals h over 6.
Okay, perfect. Cross multiply and solve here. 6 times 28, what did that get you?
168.
168 equals 8h, and then divide both sides by 8, and we get h is 21. Very good, and that's in feet, of course, for this unit. Okay, for this situation. Okay. Straightforward stuff. There's one other technique here. So again, this is like we pretty much use the same technique 3 or 4 different times now we talked about. There's other techniques to use, so let me kind of run you through a different technique here. Okay. So we're told here in real-world situations, you may not be able to measure an object directly because there is a physical barrier separating you from the object. You can use similar triangles in these situations as well. So we've got a situation right here. Okay, this is a top-down situation. We're looking like from the top down, okay, like a bird's eye view here. Here we're looking like a side view. Now we've got a bird's eye view right here. Okay, so what is this? So a hiker wants to find the distance d across a canyon. She locates points as described. So in other words, we got this canyon right here we're looking down on. Okay, the hiker starts out by locating a landmark on the other side of the canyon. Okay, like directly across from that landmark. She then puts a marker, like a rock or a pile of rocks or something like that. Okay, so maybe she like locates like a cactus or something here. Okay, right on the edge, and then puts a marker directly across the canyon from it. She then makes a 90-degree turn and walks. She knows her pace or whatever, and she walks a 400-foot kind of like straight line. Places a marker here, creating then a right triangle, right, with 400 feet right here. She then continues to walk along that straight path until she gets to W, and she just knows that that's 600 feet now. Okay, puts a marker at W, makes a 90-degree turn, and then walks to the point V until Z and X, the markers she put at Z and X, they line up. Okay, so like if this is a cactus here and these are a stone, the stone and the cactus are in a straight line. Okay, and then that's where she puts her third marker right there. Okay, what this results, or I guess fourth marker. So this results in 2 triangles, and they're going to be similar, right? How do we know these 2 triangles are similar? What can we say? So, James?
Well, they're vertical angles.
Ah, yes, vertical angles. So these are similar by angle. Very good, very good. All right, so without having to actually cross the canyon to measure it, we can get that measure across by using similar triangles, or ratios, right? So D, the distance across the canyon, over the 372 will equal what over what?
327.
Sorry, right, D over 327, that's right. Sorry. Oh my gosh, I see what you're saying. A little dyslexia there. Okay. Equals what over what? 400 over 600. Okay. If you want to, you can simplify that 400 over 600 to just 2 over 3, right? That like simplifies way down to 2 over 3. So you can actually just use 2 over 3 if you want to. Cross multiply and solve, so we get 3D equals 654. And then divide by 3. And you get D equals 218. Feet, of course. Okay? And so that allows you to find the distance across that canyon without actually having to cross it or hike down and hike back up or anything like that. You can get that distance right there. Okay? Indirect measurement. Okay? And I feel like we get the idea here, so we'll just stop there and I'll let you guys get started on your assignment. Okay? I think that's enough, I think. So, your homework for tonight is already on the Google Classroom, but I'll go ahead and give it to you up on the board here too. Page 617, numbers 3 through 15 and 18.
That is not the number.
Let me refresh.
It's pages
657.
Verse 3 through 9 odd.
Yes.
13, 18, and 19.
Well, you should
Now, in addition to this, for those of you that already finished the homework, I also have 2 10 marks assignments up as well. Okay? These will be due Monday of next week, okay? And they deal with similarity. Okay? So, you may want to get started on those. Well, I would like you to get started on those if you've already finished the book work there, okay? We stopped really early. The reason for that is normally I take people outside and we actually go and like measure the height of the flagpole. But the sun is behind clouds, and so there's no shadows, so you can't do it. So we'll see if we have time. I'd like to try and work it out, so we'll see. So maybe tomorrow, we'll see. I got to see when we're going to have sun again. All right. There are other methods of doing this, though, too, that don't require the sun. But I also want to do the one with the sun as well, because that's what we just talked about. So anyway. Yes. Okay, so I'm hoping we can do that sometime.
Can you make the triangle like any distance? Like she could have just walked like 3 feet by 2 feet.
Yeah, what she should have done, honestly, is, hang on, let me finish this.